Hello, students. Welcome to the online session of chemistry. Hope you all will enjoy this e learning. So, we will begin with the first chapter. Welcome to the chapter Chemical Reaction and Equations. So, here we are having an overview of the chapter. Whatever the activities that we are going to cover in the chapter can be seen in the slide. Let us go through the learning outcomes of the chapter. So, by the end of this chapter, you will be able to give examples of chemical reactions, represent a chemical reaction in terms of chemical equation, balance a chemical equation, list the factors that make a chemical reaction informative, interpret a balanced chemical equation, describe the types of chemical reactions with their equations and examples, explain about redox reactions with examples, give examples of oxidation in our daily life, and list methods of prevention of corrosion and rancidity. Let us begin with the terms that we know. All of us are aware about the terms changes, right? With respect to chemicals, we come across two types of changes. Those are physical change and chemical change. Physical changes are temporary in nature. The material undergoes change in its shape, phase, size, etc., but does not undergo any change in its nature. While chemical changes are permanent in nature, the substance present before the change does not exist by the end of the change and a new substance is formed. As we can see here in the example, wood is burned to ashes and that ash cannot be converted back to wood. There are various chemical changes taking place in our daily life. All these chemical changes involve certain chemical reactions. Few of the chemical changes that take place in our daily life are burning of coal, food digestion, rusting of a nail, respiration, milk to curd, water and quicklime reaction, burning of firecracker. So all these are the chemical changes that occur in our daily life. Now let us look how a chemical reaction take place. So to understand chemical reactions better, we are going to perform an activity. In this activity, we take 1 gram of calcium oxide in a beaker and then add 10 ml of water into the beaker. Now after a few minutes, touch the beaker and put a red litmus paper into the beaker. What do we observe is the beaker becomes hot because when quicklime reacts with water, it produces heat. At the same time, the red litmus paper turns blue because the resulting solution is basic in nature, or you can say alkaline in nature. Let us see another activity. Take 100 ml of water in a beaker. Dissolve a small amount of sodium sulfate. Take 100 ml of water in another beaker. Dissolve a small quantity of barium chloride in the beaker. Now we can observe a change in the color of the solutions in both the beakers. Then we mix both the solutions in one beaker and try to observe what are the changes going on. What happens is we can see a white color precipitate that is formed, and this white color precipitate is of barium sulfate and a soluble sodium chloride. So what we observe over here is a change in color. Moving to another activity. In this activity, we take 3 centimeter long magnesium ribbon, and before doing anything, we first clean this magnesium ribbon with a sandpaper, and then with the help of pair of tongs, we burn this magnesium, and then we observe a dazzling white flame that is produced. Here there are two reactants, magnesium in solid state and oxygen in gaseous state. They combine to give us a single product, that is the ash, which is also known as magnesium oxide. Now, the magnesium powder is formed due to the reaction between magnesium and oxygen present in air. There are certain reactions that proceed by formation of gas, or you can say evolution of gas. One such example is given to us. If we react zinc granules with dilute hydrochloric acid, the chemical reaction takes place and there is a formation of zinc chloride and evolution of hydrogen gas from the conical flask. So till now what did we observe is, wherever there is a chemical change, it involves both breaking and formation of bonds, a change in state of a substance, a change in color of the substance, release of heat energy, formation of precipitate, and liberation of gas, or you can say evolution of gas. So all these are the observations for chemical reactions. So if there is any chemical reaction occurring in our surrounding, then these observations might help you to identify the change. Is it of a chemical nature or a physical nature? So once we are able to identify whether the change is chemical or physical, we will learn how to represent a chemical equation. A chemical equation can be represented in words as well as with symbols also. First, we'll see how a chemical equation looks when it is represented in the word. As here we can see a chemical equation of reaction between calcium oxide and water is given. Here the description: addition of water to calcium oxide causes the formation of colorless precipitate and release of heat. In only words is quite long. A shorter description is calcium oxide plus water gives calcium hydroxide. This is a word equation. The substances which undergo the chemical change are called reactants and are always written on the left hand side of an arrow. The substances which are formed after the chemical change are called products and are always written on the right hand side. The plus sign is used to add reactants and products in the word reaction. However, the shortest form of description of a chemical reaction with least number of words and symbols is called chemical equation. How to write a chemical equation? Now, a chemical equation precisely describes a chemical reaction in a compact form by using chemical formulae of the reactants and product. The reactants and products are chemical compounds. The molecules of these compounds are made up of atoms of individual elements. The chemical formula describes the chemical compounds in terms of symbol of the constituent elements and subscripts to represent the number of atoms of each element in the compound. The formula of calcium oxide, water, and compound formed after the reaction calcium hydroxide are shown. Replacing the words in the word equation with the chemical formula of the reactants and products, we have chemical equation of the reaction of quicklime with water. SCaO plus H2O will give us CaOH twice. Can have other examples also where zinc reacts with hydrogen chloride to give zinc chloride and hydrogen gas. Similarly, sodium sulfate, that is Na2SO4, reacts with barium chloride to give barium sulfate precipitate plus sodium chloride. Let us learn how to balance a chemical equation. In a chemical reaction, an atom is the smallest particle of an element accounting for its mass. According to the principle of law of conservation of mass, mass can neither be created nor be destroyed. That means the mass of the reactants and the product after the reaction should always be equal. It further means that the number of atoms of each element forming the reactants and product should remain constant. In this way, application of law of conservation of mass on chemical equations give rise to the need for balancing of the chemical equations. In the process of balancing of a chemical equation, the elements present at the reactant site should always be equal to the elements present at the protectant site, or their masses should always be equal. Let's try to balance an equation. As we can see, here there is a reaction occurring between hydrogen atoms and oxygen atoms to give us water molecule. Here the reactants are hydrogen and oxygen atom while product is a water molecule. An unbalanced equation is represented over here as H2 plus O2 will give us H2O. First of all, we write down the elements that are involved in this chemical reaction and then the number of elements present on the left hand side as well as right hand side are written as shown. Then we place a suitable coefficient before the formula units for comparing and balancing the number of atoms of each elements on both sides. It is very important to note that the formula of a reactant and product cannot be changed during balancing of the chemical equation. Once we are done with adding of the coefficient, we need to check the number of atoms of elements on both sides of equation using this table. Let us see another example where we can balance a chemical equation. As shown, propane having molecular formula C3H8 is a colorless gas with no smell. It is used as cooking fuel. It combines with oxygen to form carbon dioxide, water, heat, and light. The balancing of the chemical equation of this reaction involves following steps. Step 1. Represent the reactants and products of the chemical reaction using correct chemical formula. The unbalanced equation is shown where C3H8 plus O2 gives CO2 plus H2O plus there is heat and light that is evolved. In step 2, we tabulate the formula units in the equation. Here carbon, hydrogen and oxygen are the formula units, or you can say the elements those are involved in the chemical reaction or chemical change. Then we try to write down these elements present on the left hand side and on the right hand side along with the species in which they are present. And step 3, we place suitable coefficients before the formula units of the unbalanced equations. So to balance carbon on both the sides, we place 3 as a coefficient before CO2 on the right hand side. Similarly, to balance hydrogen atoms on both the sides, place 4 as a coefficient on the right hand side. Now as we can see, the number of carbon and hydrogen are balanced. The remaining element is oxygen, and to do the same, we add 5 as a coefficient on the left hand side. The balancing requires hit and trial method, so you can start with any of the term of your desire. But at the end, the number of atoms of elements present on the left hand side should always be equal to that of the elements present on the right hand side. A chemical equation is not only about balancing. A chemical equation can be way more informative. So let us learn how to make these chemical equations informative by adding the physical state of the elements, heat changes during the reaction, whether an element is in the form of gas or a precipitate is formed. All these information can be obtained by the chemical equation. Let us learn how to express physical state. The state of the reactant and product as matter is more informative. Some of the notations used for expressing physical states are S for solid, L for liquid, G for gas, and AQ for aqueous solutions. For example, here iron oxide in its solid state combines with aluminium in its solid state to give iron and aluminium trioxide. In this reaction, we can get the information that iron oxide is in solid state, aluminium is in solid state, while the product obtained iron is in liquid state and aluminium oxide is also in solid state. Let us see with respect to heat changes. The following characteristics of reactants and products provide more information about a chemical reaction through its equation. Expressing heat changes. If heat is liberated during a chemical reaction, it is said to be exothermic reaction, and in exothermic reactions energy is always represented on the right hand side, while if heat is absorbed during a chemical reaction, those reactions are termed as endothermic reaction and energy here is represented on the product side along with a negative sign. If there are any gaseous product or reactant in the reaction, they may be expressed by an upward arrow, which is used to denote liberation of gas during the chemical reaction, or you can say evolution of gas during a chemical reaction. Certain reactions proceed by formation of precipitate, and if there is any solid insoluble precipitate formed during a chemical reaction, they are denoted by a downward arrow. As we can see over here, silver nitrate AgNO3 in its aqueous form is reacting with NaCl sodium chloride in aqueous state, which gives us AgCl silver chloride white color precipitate. All this information makes a chemical equation very informative, where just by looking the chemical equation we could understand about the conditions of a chemical reaction or the states of reactant as well as product. Any chemical reaction involves formation and breakage of chemical bonds of reactants to form the products. There are four main types of chemical reactions. They are combination reaction. In these type of chemical reactions, two or more reactants combine to form a single product. As here we can see A and B combines to form AB as a single product. The next one is decomposition reaction. It is totally opposite of combination. Here a single reactant decomposes into more than one compound or element. Third one is displacement reaction. In this type of reaction, one reactant element displaces other element from its compound and takes its place. Fourth one is double displacement reaction. Here exchange of positive and negative radicals of two reactants take place, causing the formation of product as a precipitate. We'll study all these four types of reactions in detail. Let us first begin with chemical combination. As I told you, in chemical combination reactions, two substances combine to form a new substance, or you can say two elements, two compounds, or one element and one compound combines to form a single product. Let's see with an activity. Take a small amount of calcium oxide in a beaker. Now pour water into the beaker. Touch the beaker and we will observe the changes. In this activity, we observe that the beaker becomes hot. So we can say that a large amount of heat is liberated during the reaction between calcium oxide and water. Here two reactants, that is calcium oxide and water, combine to produce a compound known as calcium hydroxide, and this reaction is called as chemical combination reactions. Let's see a few more examples of chemical combination. For example, burning of coal, quicklime in water, slake lime with air. One very important is respiration, reaction of nitrogen and oxygen to give nitric oxide, and reaction of hydrogen and iodine to give hydrogen iodide are few examples of combination reactions. Let's proceed with an activity to learn about chemical decombination, or you can say chemical decomposition reactions. Here we'll see an activity of heating of calcium carbonate. As you can see the setup, we take calcium carbonate, which is commonly known as limestone, in a boiling test tube. Then we place a delivery tube with a cork on the tube, heat the boiling test tube using spirit lamp or a Bunsen burner. Then we put a matchstick near the open end of the delivery tube. The gas evolved during the heating process comes out through the delivery tube and it turns off the matchstick. The white precipitate is formed at the bottom of the boiling tube. In this reaction, the compound calcium carbonate decomposes and breaks down into calcium oxide and carbon dioxide gas. So as we can see, we have a single reactant that is giving us more than one product. This is one of the important characteristics of decomposition reaction. Let's see another example. We take 0.5 gram of lead nitrate in a boiling test tube. Then we heat this lead nitrate through the Bunsen burner And as we can observe, a brown color gas is coming out. In this reaction, compound lead nitrate decomposes or breaks as a reactant when heated. This is why the reaction is called as thermal decomposition reaction and it is endothermic in nature. Here lead oxide is the first product which precipitates at the bottom of the boiling tube. The brown color gas coming out of the boiling tube is nitrogen dioxide. It passes through the delivery tube and gets collected in the collecting jar. Now, decomposition reactions can be achieved by passing electricity and those reactions are known as electrolytic decomposition. Here we'll see electrolysis of water. So as the setup is shown, we'll drill two holes at the base of a mug, insert two carbon electrodes into these holes using two rubber stoppers. Then connect two electrodes to a battery. Immerse the electrodes in water by filling the mug with liquid. Then we add few drops of dilute sulfuric acid. Here dilute sulfuric acid is necessary as water is not a very good conductor of electricity. Hence ions are produced through this dilute sulfuric acid. Then we observe gas bubbles are collected in the test tubes. In this reaction, the compound water decomposes or breaks as reactant on passing electricity. This reaction requires energy in the form of electricity and is endothermic in nature. Hydrogen is the first product which puts off the candle flame. Some decomposition reactions can occur in presence of light. Such reactions are known as photodecomposition reaction. Let us study photodecomposition with an example of silver bromide. Take silver bromide in a watch glass, observe its color. Now place this watch glass under sunlight for some time. And then observe the color of the chemical changes. In this reaction, the compound silver bromide decomposes or breaks as a reactant under sunlight. This reaction requires energy in the form of sunlight. This is why it is called a photochemical decomposition reaction. So let's move to the third type of chemical reaction, that is displacement reaction. Here we will perform an activity to study displacement reaction. Let's take a conical flask, tie a balloon on its mouth. Take a small quantity of zinc dust in the flask. Slowly add dilute hydrochloric acid into the flask. Put a cork on the flask and now observe the changes. We can observe gas bubbles appear from the solution and the balloon bulges out. This happens because here zinc metal displaces hydrogen from its aqueous solution to give us hydrogen gas and zinc chloride. The element zinc, being more reactive element, displaces hydrogen from its place in hydrogen chloride and forms the product zinc chloride. Hence this reaction is called displacement reaction. Always remember a more active metal will displace the less active element. Let us go through another type of reaction, that is double displacement reaction. So to understand double displacement reaction, we take lead nitrate and add it into a test tube filled with 5 ml of distilled water, and in another test tube we take potassium iodide and again add 5 ml of distilled water in that test tube. As we can observe, both these solutions are colorless. Then we mix both the solutions and we observe a yellow color precipitate. The precipitate formed over here is of lead iodide. Lead nitrate combines with iodide ion of reactant potassium iodide to form the product lead iodide as a precipitate, which is insoluble. The other product formed is potassium nitrate in aqueous state from the remaining reactants. This double exchange of the places in reactant forms double displacement. Let us learn about redox reactions. Those reactions in which reduction and oxidation takes place simultaneously are known as redox reactions. Now, what is oxidation? So the reactions involving addition of oxygen and removal of hydrogen are called oxidation reactions. The chemical reactions involving addition of hydrogen and removal of oxygen is called reduction reactions. And when oxidation and reduction reactions occur at the same time, such reactions are called redox reactions. Let us understand these reactions with the help of a simple activity where we will perform oxidation of copper to form copper oxide. Take 1 gram of copper powder in a china dish. Place the dish on a tripod stand with wire gauge. Now heat the copper powder using a Bunsen burner. Here the solid copper powder burns in presence of oxygen gas in air to give us copper oxide, which is black colored solid substance. Now the reactant copper gained oxygen in this reaction and hence it is oxidation. Now take the black copper oxide in a glass tube supported by the two stands on its both ends. Put corks with the nozzle. Pass hydrogen gas from the nozzle of the first cork and allow the gas to leave from the other nozzle. Using a Bunsen burner, heat the black copper oxide powder in presence of hydrogen gas. Now what we observe is copper oxide gains hydrogen or loses oxygen and turns into copper again. Hence, it is reduction reaction. In this reaction, copper oxide is said to be reduced and hydrogen is oxidized. Together, oxidation and reduction reactions form redox reactions. There are a few examples of these reactions in our daily life. For example, browning of cut surfaces of fruits, formation of metal oxide on metals like iron, burning of cracker, formation of black coating on silver items, formation of green coating on copper items, formation of metal oxide on the service wire during rainy season, and the spoiling of food materials due to oxidation. All these are examples of oxidation. Now, the spoiling of food materials due to oxidation is called as rancidity. Food materials containing oil or fat in them smell or taste foul when left uncovered for a long time. One very important phenomena, corrosion, is also example of oxidation. Corrosion of metals or oxidation of metals can be prevented by protecting the metal surfaces from moisture and oxygen, oiling, greasing, painting, galvanizing, and chrome plating, and by alloying. Galvanizing is a process of coating the surface of iron with zinc and provide protection from corrosion. Alloying is mixing two or more metals, a metal and a non-metal, to obtain the desired properties like strength, hardness, lightness, etc. to prevent corrosion of the metals. Rancidity can be prevented by adding preservatives like vitamin C, vitamin E, adding oxidants and keeping food in airtight containers or nitrogen atmosphere. So with that, we conclude our chapter. Thank you all of you.